So this talk is about the two measurements projects that we're doing at the RIPE NCC. One is called Test Traffic Measurements, the other one is called Routing Information Service. This talk is a sort of a follow-up on the talk I gave at the Winter 2002 meeting. So I've taken a few of the introductory slides from that talk, but if you want to know a lot of details that I'm skipping, please go to the NANOG website and look at the slides, they're still there. So the first thing I want to talk about are the test traffic measurements. And this is a project that has been going on at the RIPE NCC for about 5 years now. And the goal of the project is to do performance measurements on the internet and measure quantities like delay, loss, routing, bandwidth, jitter, whatever. From the start we want to do this right, so we're looking at one-way delays. So if there's asymmetric routing, you'll get whatever is you'll get information about both paths. We're doing active measurements, so we generate our own traffic. We don't snoop on traffic that happens to pass by, but it gives you both better control over the measurements as well as removes all privacy concerns that there might be. And our traffic is real, so we use UDP, TCP, and not ICMP, which is often treated different in our address. Since we're a service organization for ISPs, we focus on inter-provider network. First of all, because it's hard for providers to go and measure at some other site. I mean, you're a provider, there's the other guy sitting there, you're obviously interested in how the network between the two of you behaves, but you cannot easily go to the pub of your competitor and install a measurement device there. That doesn't mean that the techniques I'm presenting cannot be used for internal networks. We follow the various standards. There's an IETF working group on this, IPPM working group. They've published a bunch of RFCs, and we follow that. After we proved a long time ago that we can actually do these measurements, we have been offering it as a service to the community. Means if you're interested, you can get a measurement device from us. You plug it in, more or less plug and play. Has a well-defined environment for the measurements. After you've plugged it in, it will start measuring, and basically all you have to do is look at the results. So where do we have measurement points at the moment? There are about 80 of them all over the world. The red dots are the cities or locations where a measurement box is located. As you can see, most of them are in Europe, which is not surprisingly since we're essentially a European organization. But there's a handful on the US, and actually this plot is outdated since we made it. Two more US locations have been added. And there are also on the other side of the plot 3 locations in the Asian Pacific region. Now, these boxes and these measurements are one-way delay, and that's something you can only do if you have an independent clock in the measurement device. Now, so far we've been using GPS for that. Now, GPS is relatively easy. The clocks are a single unit, you just put it on the roof and it will work. However, what we noticed is that, okay, well, the clock as such is quite easy to operate. It's quite hard to occasionally get it on the roof. I mean, if you're ISP, you typically rent a few floors in a big building, usually in the basement, since when you have equipment there, you don't have people working there, so who needs a window? And then you come with this GPS clock and you want to install it on the roof, which means running a cable, and that often means getting in touch with the landlord or whoever owns the business, and he often doesn't allow you to just pull cables through his building, so you have to get a contractor in, etc., etc., etc. And you end up spending a small fortune to install this $500 US clock. But until recently, there were really no alternatives. That's changed when CDMA became available. For those of you not familiar with it, That's one of the third generation mobile phone standards. For some technical reason that I don't quite understand myself, the phones need a time signal, and for that reason the base stations, which are sort of scattered all over the country, broadcast a time signal. And the question is, okay, if this time signal, which is also synced to GPS, can this be used for TTM? And we looked at it, and the answer was yes. There's a company out there the company is called Underground Technologies, and the unit is called the Braces, which is essentially a cell phone where they've removed the speaker, the keypad, and the microphone, and everything else that makes it into a phone. It just produces a time signal. And you see the unit on the screen. It's about as big as a telephone. And this unit works everywhere where a CDMA cell phone will work, which is essentially North America and some parts of Asia. And you all know that the cell phone works deep inside buildings, and that's true for this unit as well. So, yeah, installation is really simple. You don't have to drill any holes or go to the outside. You simply get a hammer and a nail, put a nail in the wall, stick it to the wall, and you have mounted it for 2 cents. So this is really great. It means you can now do measurements, yeah, basically anywhere where you can make a phone call. Now let's look at the data. In the original design, we thought that it would be sufficient if we just started measuring, produced some plots, and gave them to the people hosting one of the boxes the following morning. It effectively meant that there was like a 6 to 30 hour delay between collection of data and appearance of plots on the web. That turned out to be too slow. Main reason is the angry customer calling you, yeah, the network is so slow today, and can you do something about it? And then it needs to have the plots. So to make that possible, we added a web interface on the boxes. One of them, at the URL shown on the slides, is a public demo. The other ones are access restricted to whoever owns the box. And if you go to that URL and you make a few clicks, you'll see something that's like this, which is the incoming delays for the box a couple of minutes after the data has been collected. Let me say a few words more about the slides. So, in the bottom, you see the blue line with the orange area. That's the delay. It's time going backwards. So on the right-hand side is now, and time goes backwards. And you see, well, for some reason, I just picked it up because it was a nice plot. There was a jump in the delay. The green plots shown on the other sides is a plot showing loss. Well, in this example, there was no packet loss. But if there was, you would see a red area on this plot. There's a whole bunch of buttons on the top of the plots, and there you can access other things in the box. You can tweak the configuration, you can check its health, and do a few more things. And you can also go to our website with more details. We also have our daily reports. It's only for operators. The idea of such a report is that you just look at your box and all the outgoing connections and all the incoming connections, and you're pointed to the ones that behave bad or behave very good in the last day. And here's such an example of a plot. So you have the leftmost column with the various boxes and where they are located, and then you have incoming delays, outgoing delays, and in red and green you see the good and the bad ones. And all this stuff is hyperlinked. For example, if you go to the sort of the middle incoming, you see red boxes. You see two numbers, 13 point something and 9 point something. 13 was the delay during the last day, 9 point something was the average over a long time. And all this is hyperlinked, and if you click on it, you'll get a plot showing delay over time and exactly the change in the point in time where it changed, and you can debug further from that. We also have a jitter application for all the cases where you're interested in jitter or IP delay variations, which are typically the application where it doesn't really matter how long it takes for the data to reach your site, but where it's important that data arrives with constant intervals. And applications are like voice and video on demand. We follow the IPPM metrics, and we produce nice plots like this, like the one shown on the right, which show the jitter during a particular day for a particular connection. And I could talk about the details of those plots for hours, but I won't have time for that. Other thing we've added are trends, and this is my favorite example. So we look at, what we do is, we look at delays over long times. This is a plot for one of our sites over a 6-month period from April 1st to November 1st last year. We measure median delays over that period, and we group it into 4 intervals: night, morning, afternoon, evening, which correspond to the black, red, green, and blue dots in the plots. And we just plot it. And this site was a content provider, and yeah, you see this nice trend like this. They hooked up some new customers somewhere in August. 5 minutes? Okay. Okay, well, okay, I'll try to. Okay, so I'll just keep talking to Susan shuts me off. Okay, so you saw this nice jump when they hooked up their new customers, and ever since then their network has becoming slower and slower. And this is something you can use for capacity planning. Okay, so we're also working on an IPv6 version, which will be ready for production by December. So if you're running an IPv6 network, we can actually look at performance of that. And the other measurement we're about to be added that's about to be added is bandwidth, and that's being beta tested on as we speak. Should be available fairly soon. Second part of the talk is about the routing information service, and the motivation for this is shown in this plot. You have your AS with your user in there on the left, and you have a website and another AS on the right. Couple of ASs in between, and your user calls with a complaint like, okay, last night I couldn't reach x.com, and you look at your routers, and yeah, maybe there's a looking glass on it, or you just do show BGP tables, and he says, well, it works now, and that's obviously not a very satisfactory answer. So what we do in the REST, we have so-called route collectors that collect BGP announcements, timestamp them, store them in the database. And this database can be queried and essentially gives you a looking glass with history information. And this is available to the community. And if you go, okay, so we have 9 route collectors at the exchanges listed on the slides, with about 200 pairing sessions. Altogether they see about 1,450 ASs, and that's growing by about 250 ASs a month in this year alone. We also notice, and that's shown on the right, is that more and more sites are multi-homed. So we have all this information, and let's go to the queries then. And they're available from the REST web page at the URL shown above. Simple queries are things like look for an AS at a given time. So, and what you get then is, okay, my AS say it was in the rep as follows at a given time, and all the announcements since then. Same thing can be done for prefix. You can see if your AS is actually in use, and there are some statistics. And we also have more complicated plots and queries. One thing, for example, is a hotspot web page, where we list the prefixes that have an unusually high activity rate during a given day. And this is just a screenshot taken a couple of weeks ago. And what you see is there was a prefix 193 something something / 24, originating from some AS, which produced something like 18,000 updates in a particular day. And all this hyperlinks. If you click on the prefix, you actually get an overview of all the announcements that were done, where they were coming from, what the path was, etc., etc. And I've just shown the first few lines of this page. It goes on for another 18,000 more lines. Next thing we have is a list of Martians, and that's really a list you don't want to be on. These are all the prefixes that somehow shouldn't appear on the internet for some reason or another, as in documented in Bill Manning's internet draft on that. So loopback, RFC 1918, former class D&E space, whatever. And we produce a list of everything that we still see, even though it shouldn't be there. And that's the list shown on the right. As I said yesterday, we also have BGP beacons for flapping studies. The prefixes here, and these are prefixes that are announced at fixed times and then withdrawn 2 hours later. And this is something we have been running for about a month. We haven't really had a chance to look at the data, but this is, if you want to look at flapping and dampening and things like this, these are prefixes you can use for that. So, now that you've seen all these things, suppose you want to participate. Well, it's really quite simple. For test traffic measurements, you have to buy one of our boxes, which can be done at the URLs shown on the slides. Basically, gives you a form, asks for an IP address and a few other bits and pieces of information, like where to send it. We'll send you a box and an invoice, you plug it in, and you can start looking at the data. For the rest, it's even simpler. If you're at one of the 9 IXs I mentioned earlier, just send us your peering details, either by mail or by filling in a form. And 1 or 2 days later, we'll have the peering set up and your data will appear. And then, for more information, here are the URLs and the contact addresses. And that's all I wanted to say this afternoon. Questions? No questions? Still recovering from lunch? Yes?